This is prototype 2 of converting the Arrma Granite into a lawnmower. What I'm going to do is I'm going to attach a metal frame to the front of the Arrma Granite. Inside that frame is going to be the mower engine and the cutting blade. The frame is going to be attached to the front of the Arrma Granite via a hinge. So as the vehicle drives along the terrain up and down slopes, the frame can actually flex up and down, so that the blade and the motor actually are parallel to the ground at all times, which will stop the frame from breaking in two, which was happening with the previous one. And I used C-channel metal aluminium frames, so I sketched up the entire thing first of all, how it would look, the size, the dimensions, how the aluminium frames would actually join together is also modelled. How the frame is going to attach to the Arrma Granite was modelled first. The hinge was modelled as well, so I knew everything would fit together and everything would work before I started 3D printing and constructing and cutting and sawing and all that other work. So here is the hinge system. It's printed in PETG, so it's incredibly strong. It's got an aluminium bar going through it. It's actually got 3 bars and they're all held together by screws. Then I designed and constructed the frame separately, and as you can see, the aluminium C-channel bars are held together and replaced by PETG, and that's to stop them wiggling around, especially if I use screws. But there's also screws as well, which was a PETG mounts, and the bars to make it extra strong and tough. And then I designed these universal wheel mounts, so they screw onto the bottom, and that allows me to put on any type of wheel that I want, because I haven't decided on the wheel yet, and I think that's going to be very important. Time to go on the grass. Pretty nervous.
Might need bigger wheels.
Okay, so I've upgraded the wheel. So these are the old wheels, these are the new wheels. They're twice as big. Slides up and down, just so that I can go left and right a bit better. But I've added as you can see, a little screw system here, so I can adjust how much it can go up. Now, I'm going to run it basically straight up the 30-degree slope. It's going fine. It goes over the grate. Let's see how good the wheels are. I know they're stuck. The wheels are stuck, so I think the wheels are too smooth. Broke again. It's working really well until it broke. Okay, so I fixed the frame, 3D printed more pieces, made it stronger. I'm going to try and drive it again. Okay, so here's another test. This is the actual lawnmower without the blade. So it's got a 40-volt battery. It's got the switch. It's got the motor with gear drivers. It's held together with these hinge pins, so you can make it higher and make it lower. You can move it left and right, depending on how you want to cut. So right now it's not a cutting test. The test is to see if the car and the frame can actually drive around with the added weight. So this and this, it's about 10 pounds. absolutely amazing. Okay, now I'm going to do a turn. It's having massive difficulty turning. Huge turning difficulty. I'm going to try and steer it again. Doesn't seem to be steering. So it looks like the problem is that there's too much weight at the front. So when I'm on a slope, all the weight is put onto, first of all, the front of the switch. So when I push down the spring, the motor runs. And when I take my finger off, it stops running. Now, we want this to always run when we're mowing the grass. Key. So the key slides in into that. There we go. Now it's fully on. And if there's an emergency and you want to take the key out and stop it, just pull it and it stops. Cutting test number 2. Insert the blade key. Okay. Go. Definitely needs to be up and down wobble. Okay, something just hit me there. Not sure what it was. So, is it cutting? Woo! It's fucking cutting the grass. Fucking great. Fucking great. Look at that. Ooh. Amazing. There's a turn. Turns like, doesn't turn very good. After I took it apart to take out the batteries, to clean it, I noticed it's not grass proof. It's full of grass. Some of the grass is dry, some of the grass is wet. So if that got into the ESC or the motor, it could burn them out. So that's not really ideal. It in Google SketchUp. So it's designed in 5 different parts. Each part I'll print separately, just to see how it works. And then on top of that and I 3D printed this. It's quite strong. It was a 36-hour print that failed after 18 hours. And looking at it, it's too big. It doesn't really fit right, so I decided to break it down into smaller sections for testing to see what would work. So this was the first failed attempt. I printed this, just a small section here, which does indeed fit, but it's too flexible because the batteries are going to now sit on top. Won't really work. Then I tried this, and again it does fit quite well, and we'd print 4 or 5 of them and then kind of stack along. Again, too flexible. After another test print, this is quite strong. Again, it fits just there, and I'd have one of them here, 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 and here. I have holes here, so they all join together, and there are holes here for screws. So let's put this here. Again, the batteries are no longer going to be inside the chassis, they're going to be on the top here. And also this battery is also going to be on the top, just as a test. So we have all the pieces for the new Arrma Granite shell. So we're going to put it together temporarily first. I'll show you how it works. So we have a couple of these pieces. So we line up here. Actually the other way. here. This goes at the back here. This fits in here. This will go. Perfect. We're going to do some plastic welding. I don't want to use screws because this is quite thin. And it's going to be used as a hinge for the battery system. So it'll be a door that flips open. So we're going to try some plastic welding. Test the chassis. So it's got the batteries attached, everything attached. The motor just won't be running. I just want to see how the chassis behaves. Looks like everything just ripped off everything. This is my final test of this. So it's got the new servos. It's got a new motor and a new ESC speed controller. I've also removed the suspension as well. So we're going to try this. We'll see if it turns properly and cuts. There was a couple of reasons I think that this failed, and it's those reasons combined that I don't think I should go forward with this design. And there's the reasons are, one is I think the servos, they're not powerful enough. When you have the batteries attached and the motor attached, the blade attached, it's just too much weight pressing down, and I think the wheels are getting stuck in the earth as well, and they're not turning correctly. Now they turn fine when the car is moving forward. That's because the wheels, they're already turning, so it's easy for the servos to work. It's not possible to get a more powerful servo. I'm using the most powerful one you can get. That is 20 to 40 pounds of turning power. But also another issue is the frame at the front. So the wheels at the front, they're digging into the earth. So when the servos do turn, and the remote control car gets pushed forward, the frame doesn't turn at the same time because it's stuck in the grass. I've tried 3 different sizes of wheels and it just doesn't work. Now you could say, oh, just use really bigger wheels. But because the wheels only turn when the car is moving and there's no servo attached to turn the wheels, having bigger wheels just means it's going to get caught in the grass more, and I'm going to need more torque and more servo power to actually turn the frame to get it to move where I want to go. So I think this design got me probably 90% of the way there, and it actually works fine on flat terrain. So when it's driving around on flat terrain, cuts the grass, turns fine. But I need something that works on the slopes reliably. 25 degree, 30, 35 degrees. So I'm going to scrap this project and I'm going to start a new prototype.